In the first section, there are some trig identities, and we've covered some of those in the last section, such as the reciprocal and quotient identities. Notice that the sines and the cosines go together, the s's and the c's, and we know those as reciprocals. If the sine of theta is 1/2, then its reciprocal cosecant theta would be equal to 2. And so we've seen those before. We've also seen the tangent theta equals sine theta over cosine theta that we saw in the table, and dividing y by x is equal to your tangent, and the reciprocal to that is the cotangent. All of these identities are things that you have to memorize and be able to use without too much trouble. The Pythagorean identities are new, and it gets its name because we use the Pythagorean theorem in order to get these certain properties. If I were to look at the first part of this, you would see that if you're looking at the unit circle, this point is going to be cosine theta, sine theta, or your x and your y, and that's if this is your theta. And you also know that the unit circle is that. So by looking at this, you would see that the cosine theta squared plus the sine theta squared would be equal to 1, which would be that first identity. Now, let's take a look at that first identity and see how we get the other two identities. It's basically just a division on both sides. If I want tangent squared, I'm going to remember tangent is sine over cosine. So I'm going to divide both sides by the cosine theta squared. And when I do that, I end up with tangent squared theta plus 1 is equal to the secant squared theta, which is the second identity. And you can do the same thing for the third identity and divide by the secant, the sine squared of theta on both sides. It's your choice, but what I usually do is just know the first one, and then I do a quick division to get the other two, because these can be easily confused going forward. So that's a little bit of a summary on a review of the basic identities, such as the reciprocal and quotient identities, and introducing the Pythagorean identities. Now on the next slide, you're going to also see cofunction identities and odd-even identities. Cofunction identities are basically from the table. If you remember from the table, the sine of 30 degrees is also equal to the cosine of 60 degrees. Or you could say it's equal to the cosine of 90 minus 30 degrees. And that's how you're getting the sine of an angle is equal to the cosine of 90 minus that angle, which is this one. So you can see the pattern by looking at the table, and therefore the sines and the cosines would go together. Again, s's and c's go together, s's and c's go together, and then you're left with tangent and cotangent. Now it has to be in this order where you have pi over 2 minus theta or 90 minus theta. Cofunction identities. Odd and even identities are based on the definition of odd and even. You may remember an odd function is where you have f of negative x is equal to a negative f of x, and an even function is where it's f of negative x is equal to f of x. Those are the definitions of the even and the odd. And so the other property that these had is where it reflects. This reflects about the origin on the odd, and the even is going to reflect over the y-axis. Now when you look at the sine and cosine graphs, the sine graph is going to reflect about the origin, because as it goes up on one side, it's going down at the same rate, and therefore there's a reflection about the origin as it continues. And therefore, the sine graph, which is paired with the cosecant graph, is going to be an odd function. You would see the same pattern with the tangent. Tangent is odd, and therefore takes on those properties. Now, if you look at the green line, which is the cosine graph, notice that it reflects about the y-axis. That means that it is going to be an even function, and therefore takes on the even properties. Notice that the secant is paired with the cosine because they're just reciprocal, so they both be even or both be odd. And this is very useful, odd and even functions, for proving things, but also to simplify when you're dealing with negative angles.